Myself Srija Amar, lecturer in Department of Polymer Technology, Karnataka Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am undertaking the course of Elements of Chemical Engineering, 3rd semester. This is a recap of session 2. We dealt with pitot tube, rotameter, and wares and notches. Pitot tube is a device which is inserted in an open channel to measure point velocity. Rotameters are also used to measure the flow. Here the area is changing and pressure drop is made constant. Wares and notches wares are used to find the discharge across rivers and channels, where notches are used for finding the discharge in small tanks or vessels. Today we are going to discuss valves, pumping devices. Under pumps, we are going to deal with centrifugal pump and reciprocating pump and MCQs. First, coming under valves. What are valves? Valves are devices connected to the pipeline to control the flow of fluids. So valves come under fittings. It's used in a pipeline to control the flow through a pipeline. It's also used to control flow rate or stop a flow rate. So valves are devices connected to a pipeline either to stop or to control the flow rate. So different type of valves are there: gate valve, globe valve, check or non-return valve. Non-return valve gives unidirectional flow, whereas gate valve, it is majorly used to stop the flow rather than controlling. So this is a butterfly valve. So by opening and closing, we can control the flow of the fluid. Gate valve. In gate valve, the open and closed position is shown. When the valve is closed, it completely stops the flow of the fluid, whereas when the valve is open, the flow occurs. Next, we come to pumping devices. So what is a pump? A pump is a device which converts mechanical energy into pressure energy, and it is used to lift a liquid from lower level to higher level. So it basically uses mechanical energy to create a change in pressure energy, and using this pressure energy change, it is used to pump a material from or liquid from lower level to higher level. So in chemical engineering and industries, it is used to handle liquids, solutions or slurries. Classification of pumps, basically they are of two types. One is centrifugal pump and the other is positive displacement pump or reciprocating pumps. Reciprocating pumps come under positive displacement pumps. Rotary pump is another example of positive displacement pumps. Centrifugal pump. Centrifugal pump uses centrifugal force to maintain the force or get the force. A pump which lifts a liquid from lower level to higher level by the action of a centrifugal force is called the centrifugal pump. In a centrifugal pump, power from an outside source is applied to the shaft. The impeller rotator is within a stationary casing. So there are many parts for the centrifugal pump. One is impeller, the other is casing, suction pipe, delivery pipe. So it mainly use power is applied to the centrifugal pump. This power is used to drive the impeller. The impeller rotates, producing a centrifugal pull force, and then this centrifugal force creates a pressure difference. A low pressure is created, and with the help of this low pressure, suction occurs from the suction pipe. This it enters the impeller, the fluid enters the impeller, and again due to rotation of the impeller, kinetic energy is imparted to the fluid. So it is centrifugal pump lifts the fluid from lower level to higher level using centrifugal force. It also, these are the parts, an impeller which is in the stationary casing, which is placed in a stationary casing. The impeller plates revolving produce reduction in pressure at the eye of the impeller. The impeller plates will be rotating. This induces a reduction in pressure at the eye of the impeller. Due to this, liquid flows into the impeller to the suction pipe. Just overview. While seeing the figure, we will get an idea. So, this is a centrifugal pump. You can see the impeller which is placed inside a casing. You have a strainer, foot valve, suction pipe, impeller. This is the eye of the impeller. The center point of the impeller is the eye of the impeller, casing, then delivery pipe, shaft. Shaft is S, which rotates using power supplied. So main part is the impeller. It is also called the heart of the pump. So in this figure, we have the impeller. It has vanes, different vanes. There are 2 or 3 type of designs like open impeller. These vanes are designed in such a way that these vanes are designed in such a way that there is no restriction to the flow of the fluid. So a power is supplied to the shaft rotates, it produces a centrifugal force. With the rotation of the shaft, a low pressure area occurs in the center of the impeller. This force often opens the foot valve and the liquid enters into the casing on the impeller. The liquid also rotates with the impeller, and while leaving the impeller, kinetic energy will be imparted to the liquid. This kinetic energy, on leaving the vanes of the impeller, is converted into pressure energy, and this causes the fluid to rise through the pump. So this is a simple explanation of a centrifugal pump. Now construction and component parts. Impeller. It is the wheel or rotor that is provided with series of curved blades or vanes. So it is a rotating element. It is provided with blades or vanes. It is also called the heart of the centrifugal pump. Impeller types are different types: open impeller, semi-open impeller and closed impeller. Depending on the blades, they are divided into open, semi-open and closed. So this is the impeller blades inside the casing. Here inlet is there. This is the volute casing. This is the eye of the impeller. These are the impeller vanes. This is the volute chamber. It is connected to the discharge pipe. So, design of blades. The impeller is divided into 3: open impeller, semi-open impeller and closed impeller. Construction or component parts of centrifugal pump. Next is casing. It is an airtight chamber in which impeller rotates. It is provided with an inlet and outlet for the liquid to be pumped. The function of the casing is to convert kinetic energy imparted to the liquid by the impeller into useful pressure energy. So it's an airtight chamber. It is connected to inlet as well as discharge pipes. Casing, the main property is to convert kinetic energy into pressure energy. Types of casing: volute casing and diffuser type casing. Let us study the working of the centrifugal pump. So, basic working of the centrifugal pump is due to centrifugal force. First, when we are starting a centrifugal pump, priming has to be done. Priming is removal of air from the suction pipe and the impeller to removal of air present in the suction pipe or any chambers. So, suction pipe and impeller blades are filled with the liquid to be pumped. This is to maintain the density. As density has relation to the pressure created, priming of the pump is done. The removal of air from the suction pipeline and pump casing is called priming. So, what is priming? It is removal of air from suction pipeline and pump casing. The delivery valve is closed and power from outside sources applied to the shaft. Delivery valve is closed and power from outside sources applied to the shaft. This was explained previously. Due to centrifugal action, a partial vacuum is created at the eye of the impeller. Liquid enters the impeller due to low pressure created due to centrifugal force. Due to low pressure, liquid enters the impeller. The high pressure of the liquid leaving the impeller, it is utilized in lifting the liquid to the required height to the delivery pipe. Then the liquid rotates in the impeller. Then after leaving, the liquid contains kinetic energy, which is converted to pressure energy and which helps the fluid to lift to a particular height, the delivery pipe. In the delivery pipe, large portion of kinetic energy is converted into pressure energy. The gradual increase in flow area helps to maintain uniform flow velocity throughout. In the casing, there is a flow area which is gradually increasing in the casing chamber. This helps to maintain a uniform flow velocity throughout the discharge. Now next, coming to reciprocating pump. So reciprocating pump consists of piston or plunger. It moves backward and forward for help to pumping. It consists of a piston or plunger which moves to and fro, reciprocating back and forth in a close fitting station called or a cylinder. So a cylinder is there, a piston is placed inside the cylinder and with the crank will be rotated. With the rotation of the crank, this crank is connected to the piston. The piston will move forward and backwards, creating pressure difference and thus creating the entry of the fluid. Pumping of the fluid is done. The cylinder is connected to suction and delivery pipes. Pipes is provided with non-return valve called suction valve and delivery valve respectively. A non-return valve provides unidirectional flow. So, it contains a suction valve and as well as a delivery valve which is connected to suction pipe and delivery pipes, and it is unidirectional. It's a non-return valve or it provides unidirectional flow. A piston or plunger is connected to a crank. It's rotated by driving engine or an electric motor. By using electric motor, a crank is rotated and a piston and plunger is connected to the crank. So this is a schematic diagram of a reciprocating pump. So we have the sump here, or water fluid which has to be pumped is here. it has a crank which is rotated using an electric motor. It is connected to a piston, and piston moves inside a cylinder. This is the piston rod. So piston moves forward and backward in the cylinder. So first, on rotation of crank to 180 degree, what happens is that this piston from left side it gets to the right hand side. While moving, it creates a low pressure area here. Low pressure here. Here there will be a suction valve and a delivery valve. This low pressure opens the suction valve and fluid from the sump enters the cylinder. Then the crank is rotating. From 180 to 360, crank is rotating. At that time, this piston moves forward. There is water filled in the cylinder. This forces the discharge valve, force open the discharge valve, and it is pumped outside the cylinder to the discharge pipe. So we have a cylinder in which a piston is moving. This piston is connected to a crank using a piston rod. On rotation of the crank, the piston in the cylinder, a low pressure area is created. Here, this forces the liquid fluid to the cylinder. On return rotating of the crank, this fluid is, as the suction valve is non-return valve, it will be closed. The fluid will be forced through the discharge pipe. Working of reciprocating pump. On rotation of the crank, piston moves from extreme left to right position. On 180 degree rotation of crank, a vacuum is created which forces open suction valve and fluid enters the cylinder. It's called a suction stroke. So vacuum is created which forces the fluid inside the cylinder, and this stroke is called suction stroke. The cylinder is full of liquid, suction valve is closed and delivery valve is at a point of opening. When crank rotates from 180 to 360, the piston moves inwardly from the extreme right position towards left. This inward motion of the piston causes pressure of liquid in the cylinder to rise above atmospheric pressure, and this forces the fluid out. Thus, valve closes and delivery valve opens. Thus, there will be a delivery stroke. The liquid is forced up the delivery pipe and rises to the required height. It is known as delivery stroke. So, one is suction stroke and another is delivery stroke. Suction stroke, on the movement of the piston to the extreme right, there is vacuum created, and due to this vacuum, the fluid enters the cylinder. Then on the re-rotation of the piston from 180 to 360, there is atmospheric pressure created, and this forces the fluid through the discharge stroke, which is also called delivery stroke. At the end of the delivery stroke, both the suction and delivery valve will be closed. Reciprocating pump. Based on the reciprocating member, it is based on 3 piston pumps, plunger pumps, diaphragm pumps, based on the reciprocating member. Now, differences between centrifugal and reciprocating pumps. So, one is the means of fluid transform is centrifugal force. In centrifugal pump, centrifugal force is used as a transferring force. Fluid is transferred by displacement of volume by piston elements. When piston elements move to and fro, displacement of fluid occurs. Centrifugal pump simple in construction and light in weight. Reciprocating pump complex in construction and heavy due to more number of parts. Centrifugal pump requires less floor space and simple foundation. Reciprocating pump requires more floor space and heavy foundation. Centrifugal pump needs priming. Reciprocating pump does not need priming. It does not incorporate an air vessel. It incorporates air vessel. Discharge is steady and even. Discharge is pulsating. Centrifugal pump is operated at high speed while reciprocating pump is operated at low speed. Centrifugal pump can handle viscous fluid and liquids containing suspended fluids. Reciprocating pump cannot handle viscous or liquids, suspended solids, useful liquids. Compiled directly to electric motor, they are belt driven. Centrifugal pump is operated against the closed valve. They are never operated against the closed valve. Efficiencies are low for centrifugal pump. Efficiencies are high for reciprocating pump. Maintenance cost is low for centrifugal pump. Maintenance cost is high for reciprocating pump. Which among the following pumps need priming? Now we come to MCQs. Which of the following pumps need priming? Piston pumps, plunger pumps, diaphragm pumps, centrifugal pump. The answer is centrifugal pump. What is the unit of density? Meter per second square, kilogram per meter cube, Newton per meter square, Newton per meter square. It is kilogram per meter cube. Third one, device used either to control the flow rate or to stop the flow of fluid through pipelines are called dash. Pump, valves, screws, fittings. Example, answer is valves. Dash is called the heart of the centrifugal pump. Impeller, casing, valve, screw. The answer is impeller. Dash is an airtight chamber in which impeller rotates. Impeller, casing, valve, screw. Answer is casing. Removal of air, 6.1. Removal of air from centrifugal pump is called dash. Pumping, priming, knitting, screwing. The answer is priming. Which type of flow does a non-return valve provide? Unidirectional flow, lateral flow, bidirectional flow, linear flow. Unidirectional flow. Movement of piston or plunger in a reciprocating pump is due to the rotation of dash. Valve, crank, casing, impeller. The answer is crank. Thank you.